I'm Dr. God King. Today I'm going to present part 2 of the infinite multiplication table. Our mantra is don't memorize, derive. This means that you will never forget your multiplication table. In case you forget it, you can always derive it. In this particular presentation, we are going to talk about 3 aspects of the infinite multiplication table. The first part is the vision. The second part is a practical application of the infinite multiplication table, which I call the infinite times table Jigsaw. It's a game that can be played with fun. And the third part is how to derive content of the infinite times table Jigsaw puzzle. Our vision for the infinite times table Jigsaw puzzle is to think like a Salone Mathemagician. The Salone Mathemagician is a theoretical concept, and it's an abbreviation for a superhero mathematician. And a Salone Mathemagician as a superhero means that he or she can instantly produce the answer to any mathematical problem at any time. So this is an ideal concept, but it's an ideal that is worth aspiring towards. So that's why we are using the concept of a Salone mathemagician. In practical terms, we shall limit the mathematics to multiplication. So we shall be talking about a multiplication mathematician, and the objective is to multiply 2 numbers as fast as possible without making any mistake. So I have presented the trade-off of speed versus mistake in a tic-tac-toe board which has got 9 cells, and you can see low, medium, high speed, and few, average, and many mistakes. So the universe of mathematicians fall in one of these 9 cells, and I have called them oceans. So in the red ocean you have quite a lot of people who are slow and make a lot of mistakes when doing multiplication. These people can enhance their skills by being introduced to rote memorization methods as well as mnemonics. They can reduce their mistakes and increase their speed. But eventually they get stuck in the gray ocean and they hardly go past it. Very, very few people cross over from the gray ocean to the blue ocean, which involves making very few mistakes and having high speed. So it means that people in the blue ocean have got high speed and make very few mistakes. These are the people who have A pluses or perfect scores in exams. And I'm proud to say that my daughter in her SAT math had a perfect score and she was in the blue ocean. So when it comes to the structure of the infinite times table, in the last presentation I noted that there are 4 quadrants of the 10 by 10 multiplication table. We don't need the 11 times table, and we also don't need the 12 times table since they are inherent in a 10 by 10 table. So we are using the 4 quadrants to simplify learning of the infinite times table jigsaw puzzle. And I would advise that you create something like this, which is laminated, and you can see that in essence it's a 5 by 5 multiplication table from 1 to 5 times. So you can print this and then laminate it, and it can be used for processing. So you have 5 of these. This side is used for doing random calculations, and you can practice completing this grid for a multiplication table. The quadrant 1 grid must be mastered. It is symmetrical, so you don't need to learn all of them. You only need to focus on 15 cells. And in the first part of the presentation on the infinite multiplication table, I talked about how this could be mastered. You can also do the same for quadrant 2, and these 4 quadrants from the 10 by 10 multiplication table. And as before, you have a grid and you have a clear space, and this is also used for quadrant 3 as well as quadrant 4. Quadrant 4 is symmetrical, that's why you have these lines. Quadrant 1 and quadrant 2 are symmetrical, so you only need to know half of the content, and as before, you can laminate these 4 and together they can form a block and you can use them for your multiplication practice. Now let us look at the details, and I shall just go through it quickly. In the last presentation, we had talked about deriving the content for quadrant 1. So basically we use what's known as times table addition, and 3 times table is 1 times table plus 2 times table. So 2 plus 4 is equal to 6, 3 plus 6 is equal to 9. So, and for 5 times table, you can practice that just by using your hand. So 5, 10, 15, 20, 25. It's good to have the reference of your hand because that helps you to easily remember. So what's new is deriving the content for quadrant 2, quadrant 3, and quadrant 4. And for quadrant 2, it begins at the 6 times table, and we can say the 6 times table is the 5 times table plus the 1 times table. So 5 and 1 give you 6, 2 and 10 give you 12, 3 and 15 give you 18, 4 and 20 give you 24, 5 and 25 give you 30. So you can derive these. I like to use 5 because 5 is a big number, and then you can use another small number for it. For example, 8 times table can be said to be 5 times table plus 3 times table, so 5 and 3 give you 8, 10 and 6 give you 16, 15 and 9 give you 24, and so on. For 9 times table, it's the same thing, and 10 times table, although you can use the same thing, you can either say it's 2 times 5 times table, or for any number that you are multiplying with, you can simply add a 0. So if you're multiplying by 1, you add a 0 there, 10. If you're multiplying by 2, you add a 0, it's 20. 3 times 10 is 30, so you can do that up to any number that you want. So that's how you will be able to derive quadrant 2. Quadrant 3 can be derived in a similar manner, but this time you are concentrating on horizontal addition. So you can say 6 times table is 5 times table plus 1 times table, and these entries, you can see the row here is the same as the column there. So there is a relationship between these two tables, but you can use quadrant 1 to derive all of these tables. And it's the same thing for quadrant 4. You can use say 8 times is 5 times plus 3 times, and you can derive these quantities. So the 3 methods, or the 3 ways which you could use: rote memorization is out, so you don't use it. You also don't use mnemonics, and we have been using times table addition. And the other thing, at the end of each quadrant, you should do what's known as skip counting. So for example, 1, it's not skip counting because you basically count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But in 2, you are counting 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And 3, you can say 3, 6, 9, 12, 15. 18, 21, 24, 27, 30. So you can do skip counting, especially using your fingers. And there are also rules that you can apply. For example, if you are multiplying by 9, you would see that the two digits always add to 9. So for example, 2 plus 7 is 9, 3 plus 6 is 9, but 4 is 1. 4 minus 1 gives you 3, and then you add 6. 5 times 9, you will begin with 4, and then you put 5. So there are many ways to get these answers, and I would suggest that you focus on times table addition and then combine it with skip counting and also apply rules that relate to these numbers. So this is all for now. I hope that you have an overview of how to use this method, and I wish you all the best as you practice your multiplication table, and hope that you never forget the content of your multiplication table. Thank you very much. Bye.